Let's talk about something you rarely notice: those massive steel cables holding up our bridges and skyscrapers. They're everywhere, quietly doing their job, yet most of us walk or drive past them every day without a second thought. But these cables are the silent backbone of our cities, working tirelessly behind the scenes. These aren't picture-hanging wires, they're multi-ton giants, stretching for kilometers, doing the heavy lifting in our cities. Each cable is made up of thousands of individual steel wires, twisted together to create something far stronger than the sum of its parts. They're engineered to withstand unimaginable forces, from the weight of traffic to the push and pull of the wind. Without them, engineering marvels like the Golden Gate Bridge wouldn't exist. These cables make it possible to span vast distances, connecting communities and shaping skylines around the world. These cables fight gravity, wind, and time, bearing the weight of entire roadways and everything on them. They flex and move with the elements, yet remain steadfast, ensuring our safety and the stability of the structures we rely on. They must be incredibly strong, yet flexible enough to span vast distances. This unique combination of strength and flexibility is what allows bridges to sway in the wind without snapping, and skyscrapers to stand tall through storms and earthquakes. Today, we're going inside the factory where these titans are born. It's a place where raw steel is transformed into the lifelines of our modern world. We'll see how a simple steel wire becomes a 3-kilometer-long powerhouse. The process is a blend of brute force and delicate precision, with every step carefully monitored. It's a world of massive machines, precision engineering, and skilled workers. Every person and every piece of equipment plays a vital role in ensuring the final product is flawless. Every step, from cleaning to the final twist, is critical. One flaw could mean disaster. That's why quality control is so rigorous, with inspections and tests at every stage. The people here aren't just making cables, they're crafting the lifelines of our infrastructure. Their expertise and dedication ensure that every cable can be trusted with lives and livelihoods. So, grab your hard hat. We're stepping onto the factory floor. Get ready to witness the incredible journey of steel, from raw material to engineering marvel. We'll follow the steel's journey from raw beginnings to finished mega cable. It's a story of transformation, innovation, and human ingenuity. This isn't just about making something big, it's about making something strong, reliable, and built to last. These cables are the unsung heroes of our skylines, and today, we'll discover what makes them truly extraordinary. Let's get started. The journey begins with a massive spool of high-carbon steel wire, each coil weighing several tons. These coils, stacked like metallic donuts, are the raw ingredient for our mega cable. The steel is specially formulated for incredible tensile strength, forged at the mill before arriving here. Overhead cranes move these spools with ease, hinting at the scale of the operation. Before anything else, the wire must be perfectly clean. Any imperfection could create a weak point. Quality control starts at the gate, with workers loading spools onto the production line. A payoff reel carefully unwinds the wire, keeping it tangle-free as it enters the first stage. From here, the wire will be cleaned, stretched, and transformed. The journey has begun, and the first stop is a serious acid bath. Time to get dirty. The wire's first transformation is a brutal one, pickling in acid. This is where the journey from raw steel to high-performance cable truly begins. The process is as intense as it sounds, and it's absolutely essential for what comes next. The wire is pulled through a long trough filled with either hydrochloric or sulfuric acid. These powerful chemicals work to strip away every trace of rust, scale, and impurities that have built up on the surface during earlier stages. Without this step, the wire would be too dirty and weak for the demanding tasks ahead. Workers in heavy protective gear keep a close eye on the process. Timing is everything. Leave the wire in the acid too long, and the steel itself can be eaten away, weakening it. Too short, and stubborn contaminants remain, compromising the final product. To ensure perfection, computers and sensors monitor every second, adjusting temperature, acid concentration, and timing. This high-tech oversight guarantees that each wire is treated just right, every single time. Once the acid has done its job, the wire is blasted with high-pressure water jets. This powerful rinse washes away any lingering acid and debris, leaving the steel bright, shiny, and ready for the next step. Next, the wire is coated, sometimes with a layer of phosphate to protect against corrosion, sometimes with lime to help lubricants stick during the next phase. This coating is crucial for both protection and performance. The wire emerges from this stage, looking dusty and white, a far cry from the raw steel that entered. It's been completely transformed, inside and out. This entire cleaning and coating line stretches for hundreds of meters through the factory. It's a loud, steamy, and sometimes overwhelming environment, but every meter is vital to the wire's future strength and reliability. By the end of this journey, the wire is not just clean, it's chemically pure, stripped of every contaminant, and perfectly prepped for what comes next. It's been stripped down to its core and rebuilt with new layers, ready to face the next challenge in its transformation. The wire is now immaculately clean, but it's not yet strong enough for its final purpose. That's about to change in the next stage of its journey. Now, the wire gets its strength through wire drawing. It's pulled through a series of dies, each slightly smaller than the last, stretching the steel thinner and longer. This process realigns the steel's grain structure, making it much stronger, a process called work hardening. Drawing blocks, with powerful capstans and diamond dies, do the heavy lifting. Lubrication and water cooling are critical to prevent overheating. The noise is intense, and steam rises as the wire is drawn thinner and stronger. After several passes, the wire reaches its target diameter and strength. It's now a high-tensile powerhouse, wound onto a new spool. What started as a soft wire is now engineered to withstand incredible forces. The individual wires are ready. Next, it's time to assemble them into strands. The real muscle building begins. A single wire isn't enough to hold up a bridge, so we bundle them into strands. Each individual wire, though strong on its own, simply can't handle the immense forces required for massive structures. By grouping them together, we multiply their strength and create something far more powerful than the sum of its parts. A strand is made by twisting several wires, usually in a helical pattern around a central core. This twisting process isn't just for looks, it's essential for distributing tension evenly and preventing the wires from unraveling under stress. The most common design uses one central wire, with 6 more twisted tightly around it, a 7-wire strand. This configuration is a perfect balance of strength, flexibility, and efficiency, making it the industry standard for countless engineering applications. This intricate process happens on a strander, a massive rotating machine that twists wires together with incredible precision. The strander's synchronized movement ensures every wire is perfectly aligned and tensioned. Tension and speed are tightly controlled throughout the process. Too tight, and the wires become brittle and prone to snapping. Too loose, and the strand loses its strength and integrity. Skilled operators and advanced machinery work together to maintain this delicate balance. Computers and automated systems monitor every detail, ensuring that every meter of strand is identical to the last. This consistency is crucial for safety and reliability, especially in large-scale construction. The helical shape not only gives the strand flexibility, allowing it to bend and move without breaking, but also ensures that the load is shared evenly across all wires, preventing weak points from forming. Once complete, the finished strand is wound onto a huge industrial spool. At this stage, it's already strong enough to lift a car or support heavy machinery, an impressive feat for something made from such thin wires. But we're not done yet. These strands are just the muscle fibers of the final cable. They're the building blocks, waiting to be combined into something even greater. To build a cable that can hold up a skyscraper or span a river, we need to bundle these strands together, creating a super strong cable capable of withstanding enormous forces. The next step is the planetary strander, a marvel of engineering that weaves multiple strands into a single unified cable. This is where the real super cable takes shape, layer by layer, as the machine spins and braid the strands into a cable strong enough for the world's most ambitious projects. Let's take a closer look at how this incredible process comes together. Enter the planetary strander, the king of the factory floor. This colossal machine twists dozens, even hundreds of strands into a single massive cable. Rotating cradles hold giant spools of strands, spinning in opposite directions to keep everything aligned. The strands converge through a closing die, forming a thick, perfectly shaped cable. Immense forces and deafening noise fill the air as tons of steel are woven together. Workers in control booths monitor tension and speed, making constant adjustments. As the cable emerges, it's pumped with grease or wax to protect against friction and corrosion. This internal lubrication is vital for long-term durability. The finished cable is wound onto a gigantic reel, ready for its final layer of protection. But it's not done yet. The cable now gets its shield, a tough jacket of high-density polyethylene, or HDPE. The cable is pulled through an extruder, where molten plastic forms a seamless waterproof barrier. It's immediately cooled in a water trough, solidifying the jacket. The result, a smooth, brightly colored coating that protects against the elements. The color can be customized for visibility or aesthetics. As the cable comes off the line, it's printed with specs and coiled onto its transport reel. What began as thousands of wires is now a unified, protected structural element, ready for the toughest jobs on Earth. Making a mega cable is one thing. Proving it can hold up a bridge is another. Testing happens at every stage: raw wire, drawn wire, strands, and the final cable. The ultimate test? Destruction. In a special lab, a sample cable is clamped into a giant hydraulic rig. Engineers watch as the machine pulls with hundreds, even thousands, of tons of force. The cable stretches, holds, then, snap, outer wires break, followed by a thunderous rupture. The goal: the cable must break above the minimum strength required. This destructive test validates the entire process. It proves the materials, machines, and people did their jobs. Only then is the full-length cable certified for use. It's a violent end for a small piece, but it guarantees a long, safe life for the rest. Now, the cable is ready for the world. Let's see where it goes next. The finished cable, weighing hundreds of tons, is ready for its journey. Transporting it is a feat. Giant cranes, special trucks, or barges move it to the construction site. When you see these cables hoisted onto a bridge or stadium, you're witnessing the result of months of precision work. Each cable represents the labor of hundreds, from steelworkers to engineers. It's a dirty, dangerous process, but the result is infrastructure that keeps our world connected. Next time you cross a suspension bridge, look up. Those cables are silent guardians. They're the muscles holding up our modern marvels, working tirelessly so we can go about our lives. From a simple spool of wire to a structural titan, the transformation is astonishing. These factories and workers are the hidden backbone of our world. It's tough, essential work, and it makes everything else possible.